Okay, so what will the following code print? Okay, when compiled and run. K is assigned 2, do the following, output K, so that's 2, pre-decrement K, so K goes to 1, and then examine the value, is it greater than 0? Well, is 1 greater than 0? Yes, so go back in, output 1, then you pre-decrement it to 0. Is 0 greater than 0? No, it's not. So 2 and 1 is the output there. Had it been K minus minus, you would end up with 2, 1, and 0. 2, 1, and 0. Now the next one I've actually, I've got a clip up on YouTube for it. So let me just go up. In this video, I would like to look at the Enthuware question 2.963, which is taken from their using loop constructs section. So in this particular question here, we're given the following code snippet, a for loop, where I is set to int1, I less than int2, I plus plus, and we output I. Int1 and int2 can be any two integers. Which of the following will produce the same result? So the best way to approach this type of question is to actually plug in two values for int1 and int2, see what your output is, and then do the same thing here. Plug in 1 and plug in 3, for example. They're the two values I'm going to work with, and see do you get the same output. So we'll have a look at that now. So over here you can see the code 2.963, and now over here I have written out the code. So if, as I was saying, I'm going to plug in two values for int1 and int2, basically 1 and 3 respectively, we'll see what the output is that I get. So it starts at 1 less than 3, that's okay, and then output I, which is 1. Then we increment I and it goes to 2, 2 less than 3, that's okay, we output 2. Then we increment I to 3, I less than into 2, no, 3 is not less than 3, so we fail. So we get 1, 2 from our output. And what we've got to do is we've got to examine each of these loops to see do we get 1 and 2 based on the same values that I've just plugged in up here. So now we'll have a look at the first one. So we'll have a look at the first one, which I've just written up here. I is set to int1, I less than int2, and then the third part, the increment decrement part, if you like, is actually a method invocation, which is allowed. So what we're doing here is we're outputting the pre-incremented value of I. So it's starting out at 1, 1 less than 3, that's okay, and then we output the pre-incremented value of I, so I gets incremented to 2, and then we output 2. So we're wrong straight away. We're looking for 1, 2. We'll follow it through anyway. 2 less than 3, yes. Output, the pre-incremented value, 3. Then it goes back to here. 3 less than 3, no, that's false. And now we'll go and we'll have a look at the second one. And I'll just write that up. So here it is here. I is been initialized to int1, I plus plus less than int2. So that's I less than int2, and that's true or false as to whether you go in and do the loop, and then you post increment your I. So 1 less than 3 is correct, we go in and do the loop, and then I gets incremented to 2. So therefore we output 2 when we get to there. Then we come back and we compare 2 less than 3, that's correct, and then we post increment to 3, and then we output 3. Then we check 3 less than 3, that's false, so you end up with 2 and 3, so that doesn't give you 1 and 2 either. So now we'll go and we'll look at the third one, and I'll just go and write it up. Okay, so I've written it out here. This time it's a while loop, but it's actually very similar to the second one. But it's while I plus plus is less than int2. We're comparing the value of I, which is 1, less than 3, and that's true obviously. Then we post increment I to 2, so we output 2. And we go back up, compare 2 less than 3, correct. Then post increment I to 3, and then we output 3. Then we compare 3 less than 3, well that's false, and out we go. So we get 2, 3 for this version, number 3, and that's wrong as well. We're looking for 1 and 2. So we'll look at the next one, and I'll just write it out. This is a do while loop. So I is set to 1, do, and output the value of I, which is 1. Then while I++ is less than int 2, which is 3. So it's a post increment, so compare the value of I less than int 2 first of all. So that's 1 less than 3, which is true. So we're going to go back in and do the do while loop, and then we post increment I to 2. So when we come back into the loop, I is 2. So we do system.println now, I is 2. Then we go down to the while 2 is less than 3. Well, that's true, so we're going to go back in and do the loop. Then post increment I to 3. Execute the loop. I is currently 3 now, so output 3. Do while 3 is less than 3. Well, that's false, and we're out. So we get 1, 2, 3 in that one, and that's not 1 and 2 either. So the last option is in fact the correct answer, that none of the ones here above actually give you the answer that you want from up here, which, given the values of int 1 and int 2 being 1 and 3 respectively, we pick nice simple values for int 1 and int 2 to make it as easy as possible. That gives us 1 and 2 as output, and then we just compare these loops to see, do we get 1 and 2 as well? And we didn't. Okay, this is probably best explained by just showing you the answer. So it's 5 and 6. We'll just evaluate it and look at. Okay, so I is 1, J is 10, and K is 1. Okay, so we're do while I is less than 5. But I is going to go up. K is also going to go up, and J is going to come down. At the end, we're going to output I and J. Now, I is going to end up in 5. So you could say, all right, that's fair enough. So I is 5, and we're incrementing by 1 from 1. So that's a difference starting out at 1. It's ending up at 5. That's an increment of 4. J is at 10. It's coming down by 1. Okay, so therefore that has to be decremented by 4. So it's 6. So that would be the right answer, 5 and 6. Okay, if you wanted to work it like that. So, but look, it's worth looking at this because it explains the pre-increment and the comparison, post-increment and pre-decrement. Okay, so here you've got in the first one, I++, okay, with minus minus j is the same as if 1 is greater than 9. So the I is 1 is left alone, but that's a pre-decrement, so that's decremented by 1. So it's down to 9. That's the true or false as to whether you do the if statement. That's obviously false. But the values of I and j after the if statement are 2 and 9. So the I has been post-incremented. The next time around, there's your values of I and j. And again, it's 2 plus plus greater than minus minus 9, which is the same as 2 greater than 8. It decides as a true or false based on that. And then the values of I and j are 3 and 8 afterwards. Iteration 3 is 3 plus plus greater than minus minus 8, which is the same as 3 greater than 7. And at the end of the if statement, you've got 4 and 7 as your respective values for I and j. In iteration 4, it's 4 plus plus greater than minus minus 7, which is 4 greater than 6. And afterwards, you're talking about 5 and 6. Now, the while condition is going to fail because I is 5, and there's the value of j. So that's just to give you an idea of how those pre and post differ. Okay, the next one. Okay, this particular piece of code here, you've got a Jack is on the while loop. Jill is on that system.out.println. If you don't put in curly brackets, it's like an if statement. It only controls one statement up to the first semicolon. Therefore, you're coming along here, you've got an if, and you're saying break out of the Jill loop. And it's going to say, well, what loop are you talking about? What block of code is Jill controlling? Jill is only controlling the system.out.println. And this if statement is not inside it. If you had created Jill colon a curly bracket system.out.println C if statement and then a curly bracket to close off, then you'd have Jill with a block of code, and this break Jill would be inside it. It would be okay, and you would end up with an infinite loop, because once C got greater than, so it became 4, in other words, okay, you'd be breaking out a Jill while C is less than 8. Well, 4 is less than 8. You go back in, you output 4. If C is greater than 3, which it is, 4 is greater than 3, you break Jill. You're never getting to the else to increment it. So C is always 4. It keeps going around outputting 4, 4, 4, 4 all the time. All the time. The next one. Which of the following code snippets will compile without any errors? Assume that the statement x is assigned 0 exists prior. Okay. While false, x is assigned 3. That will not compile because that x is assigned 3 is unreachable. You can't ever execute it because the condition is false. Okay? And the compiler knows it. Okay? I'll come back to number 2. This do while loop, fine. Do something while false. Well, it's going to do that once and then it'll never do it a second time. And this one, for int I is assigned 0, I less than 0, I plus plus. That's never going to be executed, but the compiler lets it away. We know logically it will, but that's okay. This particular one, even though x is assigned 3, is never going to be executed. Java has a specific use case for it. Okay? The if false, x is assigned 3 also, although the body of the condition is unreachable, this is not an error because the Java language specification explicitly defines this as an exception. It allows this construct to support optimizations through conditional compilation. For example, if debug outputs some tracer message. Here the debug variable can be set to false in the code while you're generating the production version of your code, which will allow the compiler to optimize the code by removing the whole if statement entirely from the class file. So that's basically why. Okay, you can actually have if false because of a conditional compilation. Okay, identify valid for constructs. Assume that math.random returns a double between 0.0 and 1.0, but not including 1.0. We have to select 3 options. Okay, no initialization, math.random, whatever number that is, less than 0.5. Will that come back with true or false? That's what you need inside the middle part of a for loop between the 2 semicolons. Something that will evaluate to true or false, and it will. No increment or decrement or anything like that, and we output true. That is fine. The next one is, can you put a Boolean over here on the right part? You can't. You can't. There's lots of things you can put there, and we can read the answer in a minute, but you can put assignment, pre-increment, pre-decrement, post-increment, post-decrement. You can call a method, and you can create a class instance. This is none of these. Okay? This is the method invocation that I was just saying there. You can call a method as part of the what we call the increment decrement. This is a loop forever, And then what you've got here is a math.random less than that, you do a break or a continue. This is an invalid use of the ternary operator. Both sides of the colon, okay, should return some value. You could, if I had true or false there, you could take that whole statement there with true or false and put it inside the semicolons there, because it would work. It would come back with true or false then. So that's not correct. And this is a loop forever. If math.random is less than that, break. Yeah, that's fine. So there are the three answers to that. And this is what I was saying, what you can and can't put in on the third part of a for loop, the traditional one. The update part of the loop does not allow every kind of statement. It allows only the following: assignment, pre-increment, pre-decrement, post-increment, post-decrement. You can call a method like down here, math.random, or you can create a class instance. Okay. This particular one is fairly straightforward. If we have any difficulty, we can do it out on the board. I is 0, j is set to 10, count is set to 0, while I is less than j. So 0 less than 10, that's okay. I is going up by 1, and j is coming down by 1, and count is going up by 1. So I and count are mirroring each other, and j is coming down. So basically, I is going to be 1, count is going to be 1, j is going to be 9. I will be 2, count will be 2, j will be 8. I will be 3, count will be 3, j will be 7. I will be 4, count will be 4, j will be 6. I will be 5, count will be 5, j will be 5. And then while I is less than j, will fail at that point. So you'll end up with I, j, and count all being 5. All being 5. Okay, this one here was best explained with a YouTube video, so I put one up as well. In this video, I would like to look at the Enthuware question 2.1227, which is from their using loop constructs. And here's the question here. Given the following code, which of these statements are true? And you're giving a loop here, a for loop, values of k and m and I, and they're incremented in different parts of the loop, and what are the values of k and m at the end? We have to select three options. We'll print 3 and 2 if line 1 is replaced by a break, then the one with continue, continue, and then there's 1 or 2 others. So we'll step through each one of those in turn now. So let's look at the first one. It will print 3, 2 for k and m when line 1 is replaced by a break, which is in this if statement when I is equivalent to 2. So let's take a look at that. So we have k is set to 0, m is set to 0, and then we go into the loop and I is initialized to 0. The loop condition is true, so we go in and we increment k to 1. If I is equivalent to 2, well, it's not, because I is 0. That fails. Then we increment m by 1, hit the curly bracket, go up here, increment I by 1 as well. Is the loop condition still true? 1 less than or equal to 3 is true, so we go back in, k plus plus, increment k. If I is equivalent to 2, well, it's not. I is 1. So that fails. Then we'll do m plus plus, goes to 2. Hit the curly bracket, go up here, increment I goes to 2. 2 less than or equal to 3, okay, that's true. And we go, increment k. If I is equivalent to 2, well, it is true now. I is equivalent to 2. And what we're testing here is if we replace line 1 with a break. So if we put in a break here, that means we break out of the for loop and we output k and m, which will be 3 and 2. So it will print 3, 2 when line 1 is replaced by a break. That is correct. So A is the first one. We have to select 3 of them. Okay, so let's look at the next one, which actually the 2 of them are grouped together. It's going to be one or the other. When we replace line 2 with a continue. So K is 0, M is 0, and I is 0. K plus plus goes to 1. The if statement is false, and M plus plus goes to 1. We go back up, we increment I, which goes to 1. That's true. We go back in, increment K. If I is equivalent to 2, it's not. It's 1 at the moment. M plus plus, and then we increment our I. I less than or equal to 3, correct. That's okay. K plus plus, it goes to 3. If I is equivalent to 2, and it is, now we do a continue, which means you jump past the rest of the code to there, which brings you up to here. So you're passing the M plus plus. You go I plus plus next. So I now goes to 3. And we'll just put it in there, that's still 2. 3 less than or equal to 3, yes. Increment your K, goes to 4. If I is equivalent to 2, no, it's false now. Increment your M, M goes to 3. Hit your curly bracket, go up and increment your I goes to 4. Go over and check, is it okay to go in? It's not, because that's greater than 3. So, which will it print? 3, 2 when it's replaced by continued, or 4, 3, K being 4 and M being 3. So it's the third one here. K is 4 and M is 3 when line 1 is replaced by continuous. So we've got down as far as there now, and we've selected 2 of them. Okay, so let's look at the next one, which is it'll print 4, 4 if line 1 is replaced by I is assigned M plus plus. So we start out with K, M and I all set to 0. K plus plus goes to 1. The if statement is false. M plus plus goes to 1. Hit the curly bracket, come up, increment your I goes to 1. 1 less than or equal to 3, that's true, so we go in. K plus plus goes to 2. If I is equivalent to 2, no, that's false. M plus plus, M goes to 2. Hit the curly bracket, I plus plus, I goes to 2. 2 less than or equal to 3, that's true. K plus plus, that goes to 3. If I is equivalent to 2, it is. So now we do the statement, which is I is assigned M plus plus, which is I is assigned M followed by M plus plus in that order. So I is assigned M, which just basically makes it 2 again. M plus plus makes M 3. We then come down here and we increment M again, goes to 4. Hit the curly bracket, go up here, increment I goes to 3. 3 less than or equal to 3, that's true. In increment K goes to 4. If I is equivalent to 2, no, that's false. Increment your M goes to 5. Go up here, increment I goes to 4. That's now false. So we output K and M, which is 4 and 5. So that's false. That option there is false. So that leaves us with the last option down here, which is it will print 3, 3 when line 1 is replaced by I is assigned 4. So we'll have a look at that one now. Okay, so we've got K, M, and I. Okay, we'll go into the loop. K plus plus goes to 1. If statement is false, increment our m, increment our I as we start the loop again. It's true, k++ goes to 2. If statement is still false, m++ goes to 2. Increment our I goes to 2. The condition is true, so we go in, k++ goes to 3. If I is equivalent to 2, well it is. And what we've got to do here is replace line 1 with I is assigned 4. So I now becomes 4. We increment our m, goes to 3. We increment I goes to 5. And the condition is now false. And we output k and m, which is 3 and 3. So the last option, therefore, is correct. So the first one, the third one, and the last one are the correct options there. So number 9. Again, you're given some complicated looking code, but what is actually the problem here is that you've got a break out of point 1 and you're not inside the loop that's identified by point 1, which is up here, that for loop there. So that is a compiler error because of that. Okay, remember that a labeled break or a labeled continue must always exist inside the loop where the label is declared. And then this is a very simple one. What's the output of the following program? I and j both initialized to 0 like that using comma to delimit them. J less than 1, well that's true, so you output 0 and 0. They both get incremented to 1. That now fails, and then you output 1 and 1. So it's 0, 0 followed by 1 and 1. And that is the answer to that one.